Okay, today we are going to see about weight and mass. Mass is the amount of matter in an object, right? It's the amount of matter in an object. It is measured in kg, kilogram, right? So how will we? It is also denoted by the letter m. These are the conditions, right? We will see what is it. What is the amount of matter? The amount of matter may be, okay, an atom or molecules, whatever it is, or if you go little clearer in that, it can be proton, neutrons and electrons. This way if you can define, you can define it, right? This is right, protons or neutron and electrons. This is the matter there, right? If I am having an object, this is my object. I am having an object, right? So if there is a stuff inside, it may be a rice or beads or water, whatever it is filled with something, right? This object is being filled with something. The filling object, the filler inside it is the stuff, inside it is this is the stuff, right? For example, I am saying it can be rice or water, okay, whatever it is, to make you understand. This rice or water is the amount of matter inside the object. This stuff is the mass. So inside stuff is the mass of the object. So it is measured in kilograms, and this mass doesn't change, okay, does not change with regard to the location. Does not change with respect to the location. It is always constant. Okay, it is always constant. The amount of stuff is always constant. It doesn't change with respect to location or planet, whatever it is, right? This is the definition of mass. Now we are going into weight. Weight is the measure of force of gravity acting on an object, right? We know Newton's second law. We have studied because it is W is equal to F or W or F, whatever it is, right? F or W equal to M into A. And one other way, weight can be defined as a force, right? Weight is a force here. How will we say it's a measure of force, right? Of gravity acting on an object. How will you measure the force? If you are having an earth surface, right? We are keeping the object, whatever the having a mass there. Say you can have the 10 kg here, okay? For example, I am saying, so I am keeping this 10 kg object, okay? The same object here. I am keeping this 10 kg object, okay, on the surface of the earth. It is only calculated based on the surface where it is kept, okay, and the force acting on the surface. So here the object is placed on the earth's surface. There is a gravitational pull acting on the earth's surface. We all know what is the value for G. It is, and the earth is 9.81 meter per second square. It is there towards the center of the earth. When we move, G is 0. When we move the altitude higher or when we go deeper, the G will get reduced, right? So generally, when you are keeping the object, now coming to the subject, when you are keeping the object on the surface of the earth, there is a gravitational pull or the force of gravity acting on the object, right? So it may be acting downwards to keep it in the balanced constant condition without moving. So this object is having a gravitational pull. How will you find the weight of the object? So force or weight can be calculated by Newton's second law, that is mass into acceleration due to, that is acceleration. Force is calculated by the acceleration, how much force you are applying and how much acceleration it is happening there. So acceleration is the change in velocity per time taken. But here when an object is moving or falling down, okay, a gravitational force is being taken into account. So I am changing F, this A, right? This A we are changing into G. because as it is on the top of the earth surface, you are taking g into account. So therefore, how will you find the acceleration weight of the object? Weight or force is equal to m into g. Okay, it is measured in the unit Newton. This will change depends on the place, because it towards the center g is 0 and the altitude goes higher, it is less, and the altitude goes little deeper, it is less. So depends on the place, it will change. Okay, mass remains the constant. So if you want to calculate, okay, I'll do a simple calculation here. Okay, so if you are having a mass 10 kg, we know what is mass is 10 kg. Okay, g is 9.81 meter per second square. So how will you calculate the weight or force? How will you calculate? Into 9.81. We have to calculate. So how much it's coming? 1 minute, I'll calculate and say the answer for you. Okay, it is 98.1 Newton. Okay, this is depending on Newton is the one thing, it depends on the gravitation. That what they are mentioning here. If you are having a bag of 20 kg rice, okay, a bag of rice of 20 kg, this 20 kg rice inside it is the mass. The rice particles inside is the mass. It doesn't change. The rice particles is 20 kg. That is the 20 kg. This is the mass. It doesn't change anywhere depending on the location. But if you want to know what is the weight, you are being pulled by the, if you are having the bag, right, it is being pulled by the gravity downwards, right? So pulled by gravitational pull. So to maintain it, we are holding the bag upright, right? We are acting it upwards. You are pulling the bag upwards. So there is a force acting here, gravitation. So when we want to calculate weight or force here, we will do what? 20 kg bag of rice, mass is always constant. But when we want to multiply the gravitation, 9.81 we will do. So how much it is coming? So it is around 196.2 Newton. Okay, this is the weight. This is the condition. Here it is measured and it changes with respect to the location. It changes here. I'll write here. It change with respect to gravity or gravitational pull. Okay, this is the answer. Okay, we will see one more thing, the difference between mass and weight and their difference. Now we are going to see the difference between mass and weight. Okay, so mass is measured in kg. We have studied it is the amount of matter contained in an object or the stuff, maybe proton, neutron, electrons, anything you can take into account, right? I have explained with an example earlier, and it is constant and does not change with the location or the planet wherever it is. Okay, so it is measured using digital balance. Okay, we are using a kitchen scale I am showing here, and then the physical balance to measure minimum grams, 2 kg, 2 grams, 1 grams it is here. It is having a glass window. I think you have seen in your physics lab. Next one is a common beam balance used to measure vegetables and other things, right? Now coming to the weight. Okay, the force exerted on a mass by gravity. So gravitational pull should be there to calculate the weight of the object. So when you are having, how will you measure it? It changes from place to place, and it's using measured by balance, spring balance, right? I've shown the object here. You will hang the object this place and then you will pull it downwards, right? When you pull it up, it will, the object will bring it downwards to their weight, and you can measure the what is the weight of the object. So what is the formula? One more here it is measured in Newton. So the formula for weight is F is equal to, or W equal to m into g. Mass is always constant. G is the gravitational pull. It is 9.81 meter per second square. Okay, with this I will finish it.